All right, we are talking today about the rectangular coordinate system. The rectangular coordinate system is also sometimes known as the Cartesian plane. It was named after René Descartes, the French mathematician. But the Cartesian plane has a horizontal x-axis. It has a vertical y-axis. They intersect at 0, 0, the origin, and that breaks the plane up into 4 equal pieces we call quadrants. And you can see they go counterclockwise, so 1, 2, 3, and then 4. Now, if you're going to plot a point on that plane, you're going to plot an ordered pair. It's a pair, obviously, because there are 2 of them, but order is important. X coordinate comes first and y coordinate comes second. So when you're looking at the x-axis, you can literally look at it like a number line. And when you're looking at the y-axis, you can think of it like a thermometer. So the positive numbers go up, negative go down, positive go right, and negative go left. So to plot the point 2, 3, since 2 is the x value, then I'll go a positive 2 on the x-axis. And positive 3 is the y value, so I'll go up 3 on the y-axis. And that would be point A in the first quadrant. All right, let's try negative 2, 3. So for negative 2 on my horizontal axis, I'm going to go back 2. And then positive 3, I'm going to go up 3. And that would be point B. And it is in the second quadrant. All right, negative 2, negative 3. So we're going to go back 2 for the negative 2 of the x value, and we're going to go down 3 for the negative 3 of the y value, and that would be in the third quadrant. And then 2, negative 3, I'm going to go forward a positive 2, and I'm going to go down a negative 3, and that last point would be in the fourth quadrant. Now we have a couple of points that aren't in a quadrant at all. We've got negative 2, 0 and 0, 3. Now, when you have negative 2, 0, you're going to start at 0 and you're going to go your horizontal negative 2, but for your y value, you don't move up or down at all. So this would be our point E, and you'll notice it's not in a quadrant because it's on the axis that divides the quadrants. You'll also notice that that point is on the x-axis. It is intersecting the x-axis, and so that point is called the x-intercept, and notice that the y value there is 0. We'll be coming back to that in just a minute. All right, then 0, 3, we're going to start right here at the origin. Our x value is 0, so we don't move horizontally at all, and so we move vertically a positive 3. And you'll notice that that one is intersecting the y-axis and that the x value there is 0. So if I want to graph a line, there are several different ways that I can do that. I can make a table of values or a t-chart, and I can put in any value for x that I want to, and then find the value for y that makes the equation true. So let's say that I want to plug in positive 2. If I put in 2, I'm going to have 2 times 2, so 4 minus y is equal to 9. And I'm going to have to solve that equation. And then when I put in 3, 2 times 3 is 6. 6 minus y is 9. I'm going to have to solve that equation again. And then when I put in 4, so every time I plug in a value, I have to solve that equation all over again. So what will save you some time is if you solve the equation first. So when we say solve the equation, we mean get y by itself on one side, all right? So let's try and get y by itself on one side. That means that I need to subtract the 9 over to this side, and I need to add the y over to this side, all right? So let's start with, we had 2x minus y is equal to 9. Let's start with subtracting that 9 from both sides, and then let's add that y over to the other side. So we have y is equal to 2x minus 9. So look how much simpler it is now to plug 2 in for x. Because when I put 2 in for x, 2 times 2 is 4, minus 9 is negative 5. I don't have to solve an equation. All right, plug in 3. 2 times 3 is 6. 6 minus 9 is negative 3. Plug in 4. 2 times 4 is 8 minus 9 is negative 1. And then plug in 5. 2 times 5 is 10 minus 9 is positive 1. So we're going to take the x value and the y value and use that to make our ordered pair. So that first ordered pair would be 2, negative 5, and then 3, negative 3, 4, negative 1, and 5, positive 1. And I'm going to plot those 4 points over here just like we plotted points a moment ago. And you'll notice that when I connect those, I get a line. So this is a linear equation because it graphs as a line. Now, you can solve for y if you want to. You do not have to. However, if you want to graph this on a graphing calculator, this is not an option. You are going to have to do this because the only way to put it into your calculator is to solve it for y first. All right, so grab your graphing calculator if you would. And let's look at how we could do that same thing on the graphing calculator. So again, our equation was y equals 2x minus 9. So I'm going to go to y equals on my calculator. And remember that when I tap something on my calculator, it'll turn red so that you'll be able to see what I did. So I'm going to clear that out. And so again, our equation was y is equal to 2x minus 9. So here's my x button. It's again illuminated in red right now, so that's where I get x. And then be sure you use your subtraction button, not this negative right here. If you use the negative, you're going to get an error message. So 2x minus 9. Now, I don't know what window your calculator is set to right now, but so that all of us will have the same viewing window, if you'll go to Zoom, we want to kind of standardize your graph. So we want to go back to tens all the way around. And so that is Zoom standard. So if I choose number 6 there, Zoom standard, it gives me tens all the way around, and there's that same graph that we got just a moment ago when we drew it by hand. Now, right above graph, you can see in blue the word table. So to get to that, I'm going to hit the blue button, the second button, and then I'm going to hit graph. And you'll notice that then it gives me the table of values. And there are the same values in the table that we solved for together a moment ago. There's 2, negative 5, 3, negative 3, 4, negative 1, 5, positive 1, as well as tons of other ones. All right, so just for review there of what we did, we went to y equals and we put in our equation. We went to a Zoom 6, which was the Zoom standard, which is tens all the way around, and we got our line. And then we went to second y equals to get our table of values, and there were the same values in that table that we got by doing it by hand. All right, so we've looked at how you can graph the line by hand and how you can graph it on your calculator. If you think about it, how many points minimum do you have to graph a line? Just 2, right? So the 2 easiest points typically to plot are the x and the y-intercept. Now we mentioned those a little bit ago, that the x-intercept was where your graph crossed the x-axis and the y value would always be 0 there. And the y-intercept was where your graph crossed the y-axis and the x value would always be 0 there. So we can find the x and the y-intercepts. To begin with, a lot of you will be able to just do this in your head, all right? So for instance, if I put 0 in for this x right here, that whole term goes away. So just put your finger on top of that term. And when you do, you're left with negative y equals 9. Well, if negative y equals 9, y is equal to negative 9. It's just a little baby equation you can probably solve in your head. All right, let's do the same thing with if I put 0 in for y, put your finger over that piece right there because it would go away. And that would leave us with 2x is equal to 9. Divide both sides of that by 2 and you'll get x is equal to 9 halves. That's your x and your y-intercept. You have 2 points you could plot your line, and you haven't even had to write anything down, all right? But just to illustrate that for you and to write it out for you, what we just did mentally, we're going to put 0 in for x and find the y value. So that's what we're doing right here. Put 0 in for x and solve for y. And then we're going to put 0 in for y and solve for x. So that's what we're doing right here, putting 0 in for y and then solve for x. All right, so up here, if we finish solving, that 0 is going to drop out. So we'll have negative y equals 9 or y equals negative 9. So when x is 0, y is negative 9. So there's our ordered pair. And then if we put 0 in for y, we'll have 2x is equal to 9. Divide both sides by 2. And we'll get x is equal to 9 halves or 4 1/2 or 4.5. So there's that ordered pair, 4.50. So if I plot those 2 points and just those 2 points, you can see there's the exact same line that we got a moment ago when we plotted 4 points. Now, just to double check myself, I will usually plot a third point just to make sure that they're all falling on the same line, that I'm not getting something out here and ending up with a triangle that lets me know that I've done something wrong. So I like to plot a third point just to double check myself, but you don't have to. Another way that you could graph your line if you wanted to is you could graph your y-intercept and then count your rise over run for your slope. So lots of different ways that you can graph your line. Whatever you like best of those methods is fine. All right, then the last thing we want to talk about is distance and midpoint.